Hello everyone, my name is Shubhayan Sengupta and I'm teaching algebra today. It's class 6 algebra, just an introduction. And if you like my teachings, please subscribe to Learned Education. You will find all my teachings in mathematics as well as computers over there. So let's begin with the introduction. Let's first see what we will cover in this session. So we will be covering what is algebra first. We have to understand what is algebra before we go into the workings of the algebra. We'll understand what is an algebraic expression, what is an equation, some fundamental concepts, and how to do simple substitution in simple equations, how to find the values by simple substitutions, and then we'll have a fun quiz. So be ready for that. So we'll go ahead. Now, what is algebra? Is a generalized form of arithmetic. In arithmetic or general mathematics, we use numbers such as 3, minus 8, the whole numbers, the integers, etc., each of which has one definite value, right? So when we are doing mathematics, we deal with either a whole number or an integer, it has a definite value. But in algebra, we use letters along with numbers. Okay. Now, what are these letters? These could be letters of the alphabet. So any letter of the alphabet we can use as a part of the algebra. For example, 5x, 3x minus 4, 7, 8, examples of an algebra. Okay. Letters used in algebra are literal numbers or simply literals. So x over here is the variable. 3x minus 4 over here, this x is a variable, or it can be called as a literal, because since it is a part of the alphabet, we can call it as a literal. So 5x, 3x minus 4, over here x, then over here a, over here y, these are all variables. Okay, we'll come to what are variables later. We'll understand that in deeper context. So over here, equation like this is a very simple equation. Y plus 8 equals to 12. So for example, if you go to the market and you buy you buy a piece, a pen. Suppose you buy pen and an eraser. Now a pen costs you 8 rupees and the total cost was 12 rupees. Okay. So what is the cost of the eraser? So that's very easy, right? 12 minus 8, you get 4. But in terms of algebra, when we write this, we'll write it in this form, this equation. And when we are trying to find out the value of y, we do this kind of an operation. Since we have to minus 8 from 12 over here, we do the same thing over here, because left and right hand side has to be balanced in an equation. So we'll come to that later. We'll come to that later, but just try to understand. We are trying to find out the value of 8. So we are subtracting 8 from here so that this value becomes 0. Similarly, on the left hand side, this 8. That was the cost of an eraser, right? So this is how algebraic equations are written, and this is how you will solve it to find out the value of the variable y. We'll continue. Now, these are the variables, as I said. Variables in algebraic expression. This whole thing is an expression. 3p. And over here, these are the variables and y. What are these variables? Because use for p, right? And so let's see what is a variable. A variable is a letter representing some unknown. A variable always represents a number, but it carries varying values when written in an expression. So this variable is not this value yet, but depending on this value, which will have there are varying quantities, different values for these, and therefore So I can have 1 over here or 2 over here or maybe 100 over here. I can have similarly infinite number of numbers over here. So this whole expression will change depending on the values of these variables. A letter representing some unknown is just a repetition of that. So this is how the expression is written. These are the variables and varying values. Okay. Now, now what is a constant? Now, in an expression, you will have a variable, and normally you will have a constant value. So a constant is unchanging. A constant is a value that does not. Excuse me. So y equals to 2x plus 6. Here 6 is the constant because 6 will always remain 6 in this equation. It will not change. What will change is the value of x, and depending on that, the value of y. So there are two variables over here, y and x, and 6 is a constant. Okay. So this is a constant over here. Right. This is another example or another definition of constants. What are constants? A constant is a number that cannot change its value, as I said earlier. Now in the expression 5x plus 7y minus 2, which is the constant over here? Minus 2 over here. This is the constant. This will not change, right? So this is the concept of a constant. Now we come to the difference between an expression and an equation. We saw some equations earlier, and we did see some expressions also. But what is the difference between these two? Expression is a set of variables, constant and mathematical operations like addition, subtraction, multiplication, which forms an algebraic expression. So 3x plus 4. So this is an expression. So 3x is divided or differentiated between this constant and this variable by the plus sign, right? So we have a plus sign, we could have a minus sign over here. So a set of variables, constants and mathematical operations like addition, subtraction or division, which forms an algebraic expression. So this is an expression. This is not an equation till now. This is an expression. And an equation is a set of variables, constants and mathematical operations like addition, subtraction, multiplication or division balanced equation. So when we put equal to sign and we put a value on the right hand side, on this side of the equation 31, so I have put 31 over here. This whole thing now becomes an equation. We have an expression, but it is now equal to some value. So this has become an right now, and every time we do some operations, the left hand side of the equation and right hand side of the equation has to be balanced. It has to be the exact left hand side or on the right hand side, that has to be followed on the opposite side. So if you are doing 31 minus 4 over here, I'll have to do 3x plus 4 minus 4 over here, right? So everything has to be balanced in an equation. Okay. Now we come to some concepts or certain terms or certain vocabulary in algebra. We have seen this kind of an expression. This is an expression. Now these two, 5x and 3 or minus, these are two terms, right? Separate sign. These are two terms, 5x and minus 3. Variable, as we have seen, this is the variable, and this 5, this number, this numerical constant is actually the coefficient of x. So we are multiplying x by 5. So the coefficient of x is 5 right now. And this one coefficient, one variable, and one constant. Okay. So go on. Here again we will see what is a coefficient. We will try to understand that. What is a term, we will try to understand. So over here we have an expression 2x plus 4y minus 9. What are coefficients of x and y? These are two variables. So 2 over here is the coefficient of x, and y over here, 4 over here is the coefficient of y. So we have two coefficients, one constant, 9 is the constant over here. These are the three terms we have because they are separated by the mathematical symbols. Now do observe, this is a multiplication. We are multiplying x by 2, but this 2 and x are not considered as separate terms. So except plus and minus, if we have multiplication and the division, we won't consider it as a term. So this is a single term, 2x is a single term, 4y is a single term, minus 9 of course is a constant. So we have three terms over here, 2x, 4y and minus 9. Okay, so these are the three terms. Now operations can be carried out on literal symbols. So apart from the mathematical symbols like plus, minus, multiplication, division, the following symbols are also used. We can also use this kind of symbols, though we will not deal with this kind of symbols in class 6, but they can be used in higher algebra. These symbols can be used. So this is just for your knowledge. So we have equal to, which we have seen. We can have not equal to. This is the symbol for not equal to. We can have less than. We can have greater than. We can have is not less than and not greater than. So these symbols, not greater than, less than, not less than, equal to, not equal to, these have the same meaning as in other branches of mathematics. Okay. So these are some of the symbols that we use. Now I'll just go back to the previous slide. Missed something. We have gone through this. Let's go on. Okay. Now again we come back to what is the term. Now the various parts of an algebraic expression separated by plus or minus sign. As I said before, only plus and minus sign separates terms in an expression. Are called the terms of the algebraic expression. For example, if we have the algebraic expression 3x, then the number of terms is 1, and what is that term? 3x. This algebraic expression 3x plus 7y, over here we have two terms, 3x and 7y, which is separated by this plus sign. So there are two terms in this expression, and which are those two terms, 3x and 7y. So terms over here are 3x and 7y. And over here we have this has gone little vary. So 5 plus 3x, you have to ignore this 2. 5 plus 3x minus 8x. Ignore this 3. This is actually the number of terms. So over here we have 5, 3x and minus 8x as the three terms. So this has become little different. Anyway, so the various parts of an algebraic expression are separated by what? Plus, minus, those two mathematical symbols. Okay. Now, when we have these terms, we saw we can have a single term, or we can have two terms in an expression, or we can have three terms, and we can have many more. We can have infinite number of terms, but in algebra we have named this kind of terms. So when we have a single term, an algebraic expression only one term is called a monomial. This we have to expression having only one term is called a monomial. So when we have one term in an expression, that's called a monomial. Mono means one and mial means expression. So it's a single expression. So examples are 5x, 2y square, 6mn, 90x, 10cd, minus 11 xyz. So these are all single expressions or monomials. Now we will go on to binomials. What are binomials? Of course, binomials when we have two terms. All right. So an algebraic expression having only two terms is called a binomial. So a plus b, 41 plus 5m, a plus 4, z squared minus 4y, 5 minus 3xy. So these are all binomials. We have two terms separated by either plus or the minus symbol. Okay, so these are all binomials. Now we come to trinomial, three expressions. So we have algebraic expression having three terms is called a trinomial. When there are exactly three terms, we call it trinomial. So what are the examples? A plus b plus c, 2x plus 3y minus 5, x square y minus xy square plus y cubed. So these are all examples of trinomials. We have three terms separated by plus or minus symbol. Okay, so these are all trinomials. We can have more than this, and that will be called a multinomial. Okay, so we have now what is a multinomial? Multinomial or more than two terms is called a multinomial. So binomial is actually a multinomial because it has two terms. So p plus q over here is a binomial, but we can say it's a multinomial of two terms, p and q. This is a trinomial. A plus b plus c is actually a trinomial, but we call it in three variables a, b and c. This is a multinomial of four terms, four variables over here, a plus b plus c plus d. Now another multinomial of four terms. This is x to the power 4, 2x cubed, 1 by x plus 1. So x to the power 4, 2x cubed plus 1 by x plus 1. So there are four terms over here. So it's a multinomial of four terms, and it has one variable. In one variable x. Over here, for example, we have a multinomial of 5 terms, a plus ab plus b square plus bc plus cd. So this is a multinomial of 5 terms in 4 variables, a, b, c and d. We have a, b, c and d. So these are 4 variables, but we have 5 terms. Okay. And similarly, this is a multinomial of 8 terms. We have 5x to the power 8 plus 3x to the power 7 plus 2x to the power 6 plus 5x to the power 5 minus 2x fourth minus x cubed plus 7x squared minus x. Okay. So this is a multinomial of 8 terms in one variable x. There are no other variable over here, only x over here. So this is a multinomial of 8 terms, but in only one variable x. Okay. So these are some of the fundamental concepts we have to understand: expression, terms, coefficients, this binomial, monomial, trinomial, what is a multinomial. Okay. These are some of the basic fundamentals that we have. Now we will go into in another part or another section which is called a polynomial. Now polynomial is slightly different from what we have seen till now or what we have generalized till now. So we will go into that. Let's see what is a polynomial. Now, what is a polynomial? A polynomial is an expression made with constants, variables and exponents which are combined in addition, subtraction and multiplication, but not division. Okay? So, it can be separated by multiplication, addition, subtraction, but we cannot have a division in a polynomial. But in binomials or in general multinomials, we can have a division symbol. But in polynomials, we cannot have a division symbol. So, it is slightly different. So, the exponents can only be whole numbers 0, 1, 2, 3. It cannot be an integer. It cannot be a you cannot say x to the power minus 1. That won't be a polynomial. Okay? And a polynomial cannot have infinite number of terms. There has to be a finite number of terms in a polynomial. Now, what is an example? This is an example of a polynomial. 5xy squared minus 3x plus 5y cubed minus 3. This is a polynomial. All right. Now, these are the exponents. So, y is raised to the power 2. So, y squared. This is an exponent of y. Over here, 3x. X is raised to the power 1. You must be knowing that anything raised to the power 1 is that value itself. X to the power 1 is x. So, over here the power of x is 1. Over here the power of y again is 3. Okay? And over here we have minus 3. But we can write it this as into 1. Now, you must be knowing that anything raised to the power 0 is 1. So, I can say 1 as 1 equals to over here. X over here actually say there is no x, but I can replace this 1. So, this will be 1, 0. X, we have x to the power of 1 over here. We have y to the power 2 over here, and we have y to the power 3 over here. Now, just let me erase this. Okay. Now, I cannot have a polynomial this type. 3x raised to the power minus 2. We can have only whole numbers. Okay. An integer, negative integer. Or we cannot have a division. 2 divided by x plus 2. This will not be considered as a polynomial. So, this a polynomial and a multinomial lies. In multinomial, we can have a division. We can have powers raised to negative numbers. We can this expression would be a perfectly valid multinomial, not a monomial, but we cannot call this a polynomial. This is again a monomial, 2 divided by x plus 2, but we cannot call this as a polynomial. This is not considered as a valid polynomial. Okay, so that's the fundamental difference between monomial, binomials or multinomials and a polynomial. Now, we will go into a little bit more details of polynomials. So, these are the examples of polynomials: minus 2x plus 7, x squared plus 3x, 4x squared, 2x cubed minus 5x squared plus x plus 3. So, you will see these expressions or these terms, we have seen it in binomial, monomial, what we said was multinomial. So, this is a multinomial of 4 terms in one variable x. So, again, what is the difference between a multinomial, a binomial? Over here, negative power, power, or over here 3, these are whole numbers. They are not negative numbers, or there is no division. There is no division symbol over here. Everything is a multiplication or an addition or a subtraction. We don't have a division we don't have anything raised to the power a negative number. Okay? So these are the examples of polynomials. So again we come back to the monomial binomial. It's an expression which is having, it will have only one term, and it will have a variable, a single variable over there. So 3x can be maybe 8c, these are all monomials, only one term. A binomial expression which is known as binomial, and we can have 3x minus 2, 3x squared plus 7, or I can have one expression as 1 by x plus 7. So that is also a valid binomial, but not a valid polynomial. Okay. Trinomial again, having 3 terms is known as trinomial. So 4x squared plus 7x minus 6. This is a trinomial. We can say this is also a valid polynomial. 3y squared plus 2y minus x. So this is again a valid polynomial as well as a trinomial. But if we had something like this, x squared plus 7 by x minus 6, then that won't be a polynomial, but it would be a trinomial. Okay, so these are the differences between the terms monomial, binomial, trinomial, and polynomial. Okay, so these are the basic differences. Now we come to the concept of what is a degree, what is the degree of polynomial. You will have to learn about this degree in your 6th standard polynomial. Now degree is nothing but the highest power of the variable in that expression. So what do I mean by that? Now if we have an expression 8y minus, now 2 over y is raised to the power 1, and as I said, this is a constant, but I can say this over here the y is raised to the power 0, because if you remember, as I said, anything raised to the power 0 is 1. So minus 6 I can write as minus 6 I can write as 6 into 1. Okay, so or 6 into y to the power 0. So if I consider the first term y squared, the degree is 2. This power, the highest power of this over here in the first term. What is the second term? In this term, degree is 1, the power 1. So this is 1. In the term 3, we have y as degree 0, because this is minus 6 into y to the power 0, right? So the degree is 0. So there are 3 degrees over here, 2, 1 and 0. And what is this value? 2. So the degree of this polynomial is nothing but 2. So this is how you find the degree of polynomial. You look at the expression and find out which is the highest power to which that variable is raised to. So normally in class 6 you will have polynomials or degree polynomials in only one variable. You won't have 2 variables over there. So you have to find the highest power, and that is the degree of the polynomial. Okay. So we'll go on to the next slide. Over here we are looking at polynomial. So monomial will be a polynomial. 6 4x cubed minus 5x squared b cubed, only one term, but this is a monomial. So this is a polynomial. By we saw 6x plus 2 ab valid polynomial of 2 terms is also a polynomial. Trinomials of 3 terms is square minus 5x plus 8 w by 2 minus 2s plus t. This is a valid trinomial, but this is not a this is a valid trinomial also because 2. Okay, so this is a valid trinomial as a polynomial. Okay, and this is a polynomial of many terms. All right. Fine. Now, what are the degrees? We can have the constant as polynomial of degree 0. So, as I said, any constant is actually that variable raised to the power 0. So, if we have a constant, the degree is 0. So, 8 minus 2 by 3, these are all of degree 0. We can have degree 1 where the power is 1, the exponent is 1. So, linear polynomial, we have x plus 8, 3 by 4, x minus 6. So, these are all polynomials of degree 1. Okay. Now, we can have a quadratic polynomial where the degree would be 2. So, over here, since the highest degree or the highest power of x is 2, the degree of the polynomial is 2. So, this is a quadratic polynomial. So, we can have 3x square minus 2x plus 7 or 5y square minus 1/4. So, these are all polynomials of degree 2 or a quadratic polynomial, and we can have a cubic polynomial where the degree is raised or the exponent is raised to the power 3. So, degree 3, 5x cubed, 2y cubed, y cubed, 4. So, over here in this expression, the highest power to which y is raised or the exponent 3 over here, the degree of the polynomial becomes 3. Just wait at the slide, just have a look. These are few of the important terms, important expressions that you will have to revise again and again. Even in class 6, when you go up to higher classes also, these things will come back, these terms will come back. Okay. Now, substitution. What is substitution? When you have an equation and when you have the values of those variables, then in the equation you can put those values and find out the value of the equation. So, over here, for example, I have said x is 3, y is 6, x equals to 3, y equals to 6. Then what would be the value of x plus y? I can replace x by 3, y by 6. So, 3 plus 6, the value. Similarly, I can have y minus x. So, 6 minus 3, the value would be 3. So, this is simple equations, and I am replacing the values of the variables and getting the equation, the value of the equation as a whole. So, we have several examples over here. For example, if you take 3x minus 2y plus 4z, where x equals to 1, y equals to 2 and z equals to 5, what would be the value of this equation? I have to replace x by 1, so 3 into 1, y by 2, so 2 into 2, and z by 5, so 4 into 5. Now, I can then simplify with normal arithmetic operations. So, 3 minus 4 plus 20, and of course, you know the answer would be 19. Similarly, over here, x square plus y square plus z square, and I have x as value 1, y as value 2, and z as value 5. So, what do I get? I will get 1 square plus 2 square plus 5 square, alright, which is nothing but 1 into 1, 2 into 2 plus 5 into 5. So, we get these values 1 plus 4 plus 5, and of course, the value of the whole equation is 30. So, similarly, this equation, just have a look at it. So, over here, we are replacing 1 in place of x square. So, 1 square x square means 1 whole square. Over here, we are replacing y by 2. So, y square means 2 whole square, and z square. Z square is nothing but 5 whole square. So, if we simplify this, it will become 2 into 1 into 1 minus 3 into 2 into 2 plus 5 into 5. which becomes 2 minus 12 plus 25, and the expression when we simplify becomes, the result is 15. So the value of the equation is nothing but 15. So these are some of the simple equations we have seen, and how we can get the values of those equations by simple substitutions. So you will find this in exercises of your books, where you are given the values of those variables and you have to simply substitute those values in the equation and get the result. All right. Okay. Now we come to the fun part. We'll see what is next. Fun quiz. This is the part which is very interesting. So do you know where algebra originated? We'll come to the questions. Where did algebra originate? Or who's the father of algebra? When did the whole concept of algebra come into the being, come into mathematics? Or why are we studying this? Okay. And some simple algebraic expressions that you have to write from the statements, from this given statements. For example, Ram is younger than Ramesh by 2 years. So what would be the expression for this? Can you guess that? Think it over. We'll go over the answers little later. This is another type where the length of a rectangular hall is 8 meters less than 2 times the breadth of the hall. What is the length if breadth is b meters? So this is another statement which you have to put into the form of an expression. Think over it. You can, I'm sure you'll get it. Now, if it takes 3 matchsticks to form the letter U, then to make 4 U's, how many matchsticks would be required? So this is a very simple statement, and you can directly calculate over here how many matchsticks would be required. But how do you put it in the form of an expression? How do you make an algebraic expression out of this statement? That we will see. Okay, let's go on to the next slide. Let's see what are the answers. Okay, the beginnings of algebra has been traced back to ancient Egypt and Babylon. So that's where algebra started. That place, ancient Babylon and Egypt, that's the place from where we get algebra. The concept of algebra grew from there. And who is the father of algebra? Muhammad bin Musa al-Khwarizmi was a 9th century Muslim mathematician and astronomer who was known as the father of algebra. Okay, so this person, Khwarizmi, was the father of algebra. The word algebra is derived from his book entitled Kitab al-Jabr. Khwarizmi was one of the most famous scholars of Bayat al-Hikmah, which was Baghdad's intellectual powerhouse. This is around 13th or 14th century we are talking about. So Baghdad was one of the intellectual powerhouse in the world that time. And Khwarizmi was one of the famous scholars in that Baghdad region. And he is also known as grandfather of computer science because he also developed the concept of the algorithm in mathematics. So in computer you must be knowing that you have to solve any problem using an algorithm. The steps required to find a solution to a problem. So he was the grandfather. He's known as the grandfather of the algorithm in mathematics. Now we will see the expressions from the statements that we saw in the last slide. So if we consider Ramesh's age as x years, then Ram's age in algebraic expression is x minus 2 years, because Ram's age was 2 years less than Ramesh's age. So x minus 2 years. So let the breadth of the rectangular hall be b. That was given in the statement. B is the length of the or the measurement of the breadth of the rectangular hall. Now the length was 2 times the breadth minus 8, because 8 meters less. So in algebraic expression, the length of the hall would be 2b minus 8 meters. Okay. Now we come to the last one. In the statement it was mentioned that 3 matchsticks is needed to form the letter U. So if I have 3 matchsticks, I can form a U-shaped figure like this. Okay, so 3 matchsticks would be needed to form the letter U. So how many matchsticks would be needed to make 4 such U's? Simple, 4 into 3, 12, but we will see how it is in the form of an expression. So let the total number of matchsticks required to form 4 U's be x. So 1 U is 3. I'll have to multiply, I'll have to get this x. So therefore, x equals to 4 into 3. I simply multiply this u by 4 and u I know as 3. So I substitute the value of u over here and I get 4 into 3 or 12. So this is again a simple substitution. We are getting into the form of an equation and trying to solve it. So I got 12 as my answer. Alright. So if you like this lesson, do subscribe to Learned Education. All my teachings would be there. My name is Shubhayan Sengupta, and I would say goodbye. Thank you to all of you.